Good evening, sir.
Good evening, friends. So,
Good evening, sir.
welcome once again. I'm so very glad to see all of you uh, for this special class where we are going to cover the topics that are yet to be covered, and then we'll be able to take some doubts at all if required. Okay, so I will start from where we were, what we were discussing yesterday. So,
Good evening, sir.
good evening. Just give me a minute. I'm trying to see how we can record it.
Good evening, sir.
Good evening. Okay, friends. So, can you see my screen now? Yes?
Yes, yes, sir.
Okay, perfect. So,
Yes, sir.
yesterday when we closed the session, we were discussing about our third phase. Yes or no? Third
Yes.
phase, that is our
Yes, sir.
analyze phase. And as we discussed yesterday, the purpose of analyze phase is to find out that for the particular CTQ, the particular Y, the critical to quality characteristics of a process that we have identified, which is the root cause, meaning which what out of so many input factors we know x1, x2, etc., 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 which one of those is critical root cause. Just for example, just to recollect what example we have taken throughout this discussion. Let's say we are talking of the sweetness in a cup of tea. And what are the input factors in a cup of tea? Water, milk, tea leaf, sugar as the inputs, and the boiling temperature, boiling duration, etc., etc., as process parameters. So out of so many input factors, we want to find out which one or more than one input factors are the critical input factors that significantly affect the CTQ that we are concerned about. Is that clear to all of you? That is the purpose. And the example, another example that is shared with you, that how we will shortlist and what will be our methodology. Just think of that marriage function where initially there were 600 people present. So possible, theoretically possible, 600 reasons, all the input factors. Then we shortlisted and we tried to identify potential or probable. Potential or probable critical X factors. Once we have shortlisted that, then what we do? We conduct investigations. That means we conduct tests, and based on those investigations, based on those tests, which in our methodology we will be doing statistically testing. Yes or no? And based on our statistical test, we will know that this particular input factor or more than one also is possible are critical input factors that affect that CTQ. That is exact purpose of uh, conducting our analyze phase. So for this, what really happens and what is the methodology, that is exactly what I am going to discuss now. So just a quick recap of what we discussed yesterday. First, we need to make a list of all possible causes. For example, the list of all 600 people who are present in that marriage hall. And then we need to short list the potential or probable critical factors. So these two activities are conducted using the concept of brainstorming. That means you gather all the people who are the stakeholders, everyone who has got a stake in it, people who know about it, and then with them you brainstorm and try to list out all the possible factors. For that we have tools like fishbone diagram, we have tools like YY analysis to identify critical, potentially critical factors. Let us say once we have identified potentially critical factors, then we need to test and this testing is called statistical validation. And how that statistical validation is done, that's what we are going to discuss. So please note that what will be the situation there? We are suspecting that this particular input factor is responsible for that CT. Let us take that simple example that in a cup of tea, if the sweetness is our critical to quality, measurable uh, thing that we are going to investigate, and we suspect, and therefore we claim that amount of sugar is causing difference in the sweetness of that. What is this? This is our suspicion, which we call as our claim. So from now on, I will take this example in exact statistical terms that we are going to use. So now my claim is that the sweetness in the sugar is significantly affected by the amount of sugar that we use. This is my claim. Now I want to test my claim. What is the simplest and the common sense approach? Let us make 2 cups of tea. In 1 cup of tea, I will add 1 teaspoon of sugar. And in the second cup of tea, I will add 1.5 teaspoonful of sugar. Yes or no? Then let us check if there is a difference in the sweetness of first cup and second cup. Then we can tell that yes, sugar is having a significant impact. Is that concept clear to you? So whenever I am making a claim, then I will conduct some test on based on that about that claim, and then I will try to know whether this claim is true or it is not. So just in this case, I have made a claim that amount of sugar affects the sweetness of the tea. This is my claim. Now let me check by using some test, which will be statistical test over here, that this claim is true or not. So let us say there can be two different let us say claims. I have made a claim that amount of sugar is affecting the sweetness, and Satish, my friend, has claimed that amount of tea leaf is affecting the sugar, affecting the sweetness. Can you see that? So we will test, and in the claim that I have made that the amount of sugar is affecting the claim, if that is found true, we will agree to that. We will conduct another experiment that in 1 cup of tea, I will make a particular amount of tea leaf, and in the other cup, I will take some different amount of tea leaf, and then I will check the sweetness,
Sweetness.
and then I will know that.
So you are in mute.
Sir, your mic in use.
Oh,
Wake, sir.
perfect, perfect.
Yes.
So now,
Yes.
are you getting the situation? So the claim might be true, just as we all know that claim about this fact that the sugar is having significant impact on the sweetness, you already know that that is true. And claim also, there can be situations that the claim we have made, claim my dear friend Satish has made, that the amount of tea leaf is affecting sweetness is not true. So there can be both the situations. Claims can, and very good. Shelly is already inspired. He is having a cup of tea. Okay, perfect. So claim can be true, claim might not be true also. So there is a specific and very logical, very common sense methodology for doing this, which is called hypothesis testing. And now I want all of you to be very, very attentive and enjoy the how beautiful this theory, the hypothesis testing is. So what we do, what is the purpose? The purpose is to check whether the claim I have made is true or not. And therefore it is called a decision making practice. Now, how we go about this? So whenever there is some claim made, we write two hypotheses. So we write one null hypothesis and we write one alternate hypothesis for every claim. Take it in just as what I am telling, just follow that. There is a claim that has been made. Now what I will do, I will write two sentences. One is null hypothesis. Can you see on the screen? And another is alternate hypothesis. I will write the statement of null hypothesis in such a manner that I will say that there is no difference. And I will write the alternate hypothesis, the corresponding alternate, which is known as corresponding alternate hypothesis, in such a manner that there is a difference. So for every claim, Ravi, Bhagat, Bhagwat, Kush, I will write two statements. Null hypothesis, and I will say there is no difference between this cup of tea, which is having one teaspoon of sugar, and this cup of tea, which is having 2 teaspoons. There is no difference. This is called null hypothesis, and also I will write correspondingly alternate hypothesis. So now you know that either one of them will be correct, either null will be correct or alternate will be correct, yes or no? And
Yes.
now I have developed a very simple methodology that when I conduct that test, then I will comment only about the null hypothesis. And that will communicate my understanding about alternate hypothesis also. Let us do that and then you will understand this in a very simple manner. So are you able to understand that hypothesis testing is a decision making procedure, and hypothesis testing is conducted to establish that whether there is a difference in the two samples that we are testing. So a claim about the difference between two or more
Or
groups
more group
is
is tested.
tested for its is trueness. So what is the mechanism? Let us say in a real life situation, these are the some examples of the claim that people make. Okay, somebody has made a claim that, for example, what is the claim? Aniket, what is the claim? Reaction time affects process yield. One example of the claim. Bhagwat, another example of the claim: pouring temperature affects casting quality. Sorting time affects on time delivery. All these are various claims for real life situations. Ganeshan, can you see that?
Yes, sir.
Ramya, can you see that? Results of machine 1 are better than machine 2. There is an improvement in the performance of a player after appointment of a coach. I have taken 5-6 examples of the claim. Let us now try to write null hypothesis about and learn to see how we can write null hypothesis and how we can write alternate hypothesis. This is the symbol of null hypothesis, H naught. And this is the symbol of alternate hypothesis, H1. Sometimes it is also written as HA. Can you see that on the screen? This is the
Yes,
symbol
sir.
of null hypothesis. These are the symbols of, you can use either of them for alternate hypothesis. Null hypothesis is the initial claim specific, saying that there is no difference. Both the samples are equal. There is no impact by changing this input factor. There is no change, no impact. Okay, and alternate hypothesis says that there is a difference, there is a impact. Now let us take some examples. I will write some question and please tell me whether this is a statement of null or a statement of alternate. Let us see how much you have understood. Higher pouring temperature will increase. Is it null or alternate? Please tell me.
Alternate hypothesis.
Alternate.
Calorie consumption will affect weight gain. Null or
Alternate hypothesis.
The speed of car will affect its mileage.
Alternate hypothesis.
Reaction time affects the processing. Null or
Alternate hypothesis.
alternate hypothesis. Now I will ask further. Pouring temperature has no impact on the process.
Null hypothesis.
Calorie consumption has no impact on weight.
Null hypothesis.
The speed of a car has no impact on its mileage. Null
Null
hypothesis.
hypothesis.
Reaction time has no impact on process heat. Null hypothesis.
Null hypothesis.
So these are
Null
the
hypothesis.
examples of null hypothesis. Yes or no? And can you see
Yes.
that for every null hypothesis there will be a corresponding alternate hypothesis. So this null hypothesis and alternate hypothesis always work in a pair. For every null hypothesis there will be a alternate hypothesis or vice versa. So now please tell me, for this null hypothesis, Ganeshan, can you help me with this? Calorie consumption will affect weight gain. This is the alternate hypothesis. What is the corresponding null here? Calorie consumption has no impact. Yes, Vijay Kumar,
Yes.
can you help me with this?
Sir. Yes, sir.
There is one null hypothesis. Reaction time has no impact on processing.
Yeah.
What is the corresponding alternate? Reaction time affects
Affect
the
the.
yes or no? So now we know
Yes,
that
sir.
the null hypothesis and alternate hypothesis, they work in pairs. And for every null hypothesis, I can write and I will write a corresponding alternate hypothesis. Yes or no? Now please tell me, if I have got a statement of null and I have got a statement of alternate, only one of them will be correct. Either null will be
Yes.
true or the alternate will be true. I want to know which is true. So I will conduct my test and I will then comment only about null. And that will communicate what I believe. Okay, and that is fact number one. Fact number two, I will comment only in two possible ways. One is that I reject null hypothesis or I fail to reject null hypothesis. Only two possibilities are there. Now this covers all possible situations. If I say I reject null hypothesis, what does that mean? I am going with the alternate.
Alternate
I am
hypothesis.
accepting the alternate hypothesis.
I will not say I am accepting, I will say that I am going with, because further investigation is required. Okay, so if I reject the null hypothesis, that means I am going with the alternate hypothesis.
Alternate
Or
hypothesis.
I fail to reject null hypothesis.
Sir, I have one doubt here. So we can go with case by case study on the case by case. It will be apply on the null hypothesis as well, alternate hypothesis, right?
I will repeat.
So it depends on the case.
The methodology that I am going to explain is applicable in every scenario. Just please keep confirming that you have got every point of you are agreeing. I will write two hypotheses for a claim: null and alternate. Vijay, is that clear?
Yes.
Yes, sir.
Then
Yes, sir.
I will comment only about null. And in only two possible manners. I will say I reject the null, or I will say I fail to reject the null. If I say I reject the null, what does that mean? I am going with alternate.
Alternate.
If I
Yes.
say I fail to reject the null, that means I am going with the null.
Null.
Is that clear? So that is a standard methodology, and that will communicate what is the outcome of our investigation, that is our hypothesis test. So now let us see some more examples. Supplier 1 delivers faster than supplier 2. Null or alternate?
Alternate.
Null.
Alternate
Machine
hypothesis.
1 produces parts faster.
Alternate.
Hypothesis.
Going rate in another region is more than.
Alternate.
Alternate. Transaction
Action
time of vendors are not same. Are not same. Alternate. Alternate. Null is a statement of equality. Yes. So now all these are alternate hypotheses. Now let us see. Delivery time of supplier 1 and supplier 2 are equal.
There is some echo. Sorry to interrupt. There is some echo.
Null.
Sir,
Your voice is echoing, sir.
Actually, let me contact them. I don't have the really access.
Hello. Hello. Is it better now?
Yeah, it's working.
Okay, perfect.
Yes, sir.
So that's better. Anyways, so let us. Have you understood all the above four are examples of alternate? Yes, because
Yes,
they are saying
yes.
there is some difference or there is some impact. Now, when I say that delivery time of supplier 1 and supplier 2 are equal,
It's null.
null hypothesis.
Null.
Machine 1 and machine 2 produce parts at equal rates.
It's null.
Null hypothesis. Going rates are equal.
Null hypothesis. Equal.
Null hypothesis.
Equal. Null hypothesis.
Hello, Bhagarji, ma'am is not picking up. So can you please contact her? Because I need to. Yeah, sure. Because just tell her to give me the whole so that I can either record and then. And I need to know mute and also. Okay. Thanks. Okay. So now we know that there will be a null hypothesis and a corresponding alternate hypothesis. Gaurav, Prasad, Balaji, Purushottam. And I will comment only about null. Only in two possible ways. Either I will say I reject the null or I will say I fail to reject the null.
Null.
Right. And this is how I will communicate my understanding about what I think to be. So, hypothesis testing is a decision-making procedure. It is an experimental procedure to test whether a claim about the difference is a true difference or not. Null hypothesis is a statement of no impact. Alternate hypothesis is a statement of impact. And now, please note one more thing, that null hypothesis is the original belief of the organization. Because if organization believes that the quantity of sugar does not affect the sweetness, that is why they are careless about the amount of sugar. Yes or no? If they believe that quantity of sugar is affecting sweetness, they would be careful about that. Or let us say that the organization is working with both the suppliers. That means organization believes that both the suppliers are. Hello. Okay. Sure. So if the organization believes that both the suppliers are suppliers' performance is equal, that is exactly why they are working with both the suppliers. So please note and remember that null hypothesis is the original belief of the organization. Now, we are very clear about three facts. That null hypothesis is based on the common knowledge, which is the original belief of the organization, and alternate is a claim made by some expert or based on some observations of a experiment. If that is clear, now we will learn another concept. Then I will come back to how this null and these are related. This is about type 1 and type 2 error and confidence level and power of test concept. Now, just look at the screen very, very carefully. It is something very simple. Just looking a little intimidating. It is something very, very simple. On the x-axis, first just look at the x-axis. On the x-axis, I have written the reality about the product, that it is a good product or it is a bad product. This is what I have written on the x-axis. Can you see, everyone? Govindan, Vijay, Shelly, Aniket, Dr. Tasneem,
Yes, sir.
on the axis, what is on the x-axis?
Yes, sir.
The reality about the product. And on the y-axis, what is there? My decision about the product.
Decision.
Because what happens in statistics is that I make my decision based on the sample. So that can be correct or that can be incorrect also. Okay, I will give you one example. Suppose we go to the grocery shop, we want to purchase a bag of rice and we draw a sample from the top of the bag, and based on that sample, we make a decision about the whole bag. Yes or no, Dr. Tasneem?
Yes, sir. True, sir.
And therefore, there is always a risk involved that decision might be true, that decision might not be true also. Because let's say if the shopkeeper wants to cheat us, what we will do? Just I want to.
You will keep up the.
Yes, he will put up the good quality rice on the top of it because he knows that the customer
Yeah.
will come, they will open the bag, they will draw the sample obviously from the top. Okay. The idea is that whatever decisions we make based on the samples in statistical analysis, there is always some risk. There is always some risk that the decision might not be correct. And there is no situation where we can be 100% sure. Okay. So let us say if my product is actually good, but I have rejected it. Possible or not? My product is actually good, but my quality checker, based on his sample, or maybe based on his error of measurement or something, he has rejected it. Possible? Or maybe it is also possible that my product is actually bad, but my quality checker has accepted it. Possible or not? Can you see both these red blocks? Aniket, Govindan, Vijay? Yes?
Yes, sir.
Yes, sir.
Okay, thanks.
Recording in progress.
Okay. So, this situation where the product is actually good, but we have rejected it, is called manufacturer's risk or alpha. Whose loss is this? The product is good. Govindan, can you see that? Product is actually good, but our sampling methods have rejected it. Whose loss is this? Whose risk is this? Manufacturers.
Manufacturers.
Therefore, just try to remember this block and this will clear everything for you. If the product is actually good and we have somehow rejected it, this risk is called manufacturer's risk, also known as type 1 error, and the symbol is alpha. And therefore, the corresponding confidence, let us say I give you one example, let the risk is 5%. Then the confidence is 95%. Yes or no?
Yes, sir.
Yes.
So this is the situation. The product is actually good and I have accepted it and I have got a confidence that I will accept the good products. Confidence level is 95% and risk of rejecting a good product is 5%.
5%.
Similarly, here also this situation is also possible. The product is actually bad, but my decision is that I have accepted it. Whose risk is this? Consumer's risk. Yes or no? Consumer
Yes.
has received a bad product. This is consumer's risk, and the symbol for this is beta. Is the concept very clear to you? All of you can visualize this. So, typically, manufacturer's risk is taken as 5%. We design, and this is the industrial standard. We design our sampling processes in such a manner that we take, this is a standard industrial practice, that the manufacturer's risk is taken at 5%. I am willing to take a risk of 5%. You can decide you want to take a risk of 2% or whatever. Generally, what is the standard practice? That is what I have discussed with you. Now, the same concept can be further taken as for this hypothesis testing also. Suppose, what is the reality about the null hypothesis? Please note that null hypothesis is manufacturer's original belief, organization's original belief. That's what I told you. Yes, null hypothesis is organization's original belief. This is what an organization believes. So, the reality about the null hypothesis, it is true. But because of my statistical analysis, there is a risk involved that I can reject it. So, the risk of rejecting a null hypothesis, which is actually true, is known as manufacturer's risk. Just by looking at this graph and just by whatever I have discussed, I am very sure that you will be able to reconstruct this sentence in your mind. The risk of rejecting a null hypothesis which is actually true is known as alpha risk or manufacturer's risk. Can you visualize this? Can you think of how this sentence is coming? Balaji? Something? Very simple. The risk of rejecting a null hypothesis which is actually true is known as type 1
Alpha
or alpha risk.
risk.
And typically we consider, everyone agrees that let us take a risk of 5%. Let us take a risk of 5%. I can afford the risk, taking a risk of 5%. That's what industrial practice is. So now let us learn about another concept which is called p-value and the decision rule about the p-value. What is the p-value and what I will tell you after a couple of minutes. First I will tell you the decision rule. Ravi, Ritesh, Vijay, the decision rule is if p is low, null shall go. Such a simple decision rule. If p is low, null shall
Oh,
That means I will find out the p-value. If p-value is less than 5%, and we will talk in terms of probability. So we will say if this less than 0.05. So if p is less than 0.05, what will happen to null? Null shall go. That means I will reject the null. Such a simple thing. From the experiment, I will calculate the p-value. And I know and I will find out what is the value of p from that. Yes, if p-value is less than 0.05, I will say I reject the null. Bhagwat?
yes, sir.
Aniket? Or if it is more than that, I will say I fail to reject the null. As simple as that. Shelly, can you see that? Only two possibilities. Dr. Taslim, I reject the null or I fail to reject the null. Now I will ask and let us see how have you understood or not. Let us say I conduct the experiment. Dr. Taslim, I am asking you. The value, p-value is 0.02. Is it less than 0.05 or more than? Less.
Less.
Correct?
Yes.
Less than.
P is low,
Reject
shall,
the null.
Null shall
Go.
go.
null shall go. Reject the null.
Yes.
Suppose, push. I calculated the p-value came out to be 0.75. Is it more than or less than 0.05?
More than
More
0.05.
right? So then you say that I failed to reject the null.
Reject the null.
I failed to reject the null. Is that clear to all of us?
Yes, sir.
Such a simple thing. So can you people repeat after me? If P is low, null shall go.
Shall go.
If P is low, null shall go.
Yes, if P is low, null shall
Null shall
Shall
go.
go.
lower than what? Lower than the risk we have agreed to take. Typically it is 5%, therefore it is 0.05. But in some of the situation, let us say in medical research, we can say that okay, I am going for I don't want to take even 5% risk, I want to take 2% risk. It is possible. In most of the industrial cases, Satish, Govindan, Purushottam, Ravi, Balaji, in most of the industrial cases, it is taken to be the 5%. But there is no bonding on you. If it is, the matter is so very sensitive. Let us say you are testing a drug for medical purposes. Then you will say that, okay, I want to take only a risk of 2% of my decision going wrong. So, null shall low means lower than the risk you have agreed to take as a team. Okay, so let me ask one more time, and who is going to ask? Who is going to
Yes.
answer me? Maybe Balaji will answer. Okay, so Balaji, let us both of us agree that we will take risk of only 2%.
Yeah.
Okay, sir.
Let us agree. This is a life and death situation. We are testing a new drug for cure of cancer. So let us say that I will be willing to take a risk of only 2%. So what is the corresponding probability value? 0.02. 0.02. Now, I conducted the test and the p-value I got is 0.01.
Yeah, null shall go.
Yes, p is low, null shall go. I got a
Shall go.
value 0.03.
Failure to
Null
know.
shall
I
go.
failed to reject the null.
I failed to reject. So, and Shally, both you and me agreed that we will take a risk of 5%. What is the corresponding probability? 0.05. Now the value I observed is 0.3.
Yeah. So
You
we'll
saying
reject
it
them.
is less, null shall go. So do you know,
Yeah.
now you realize that Balaji is saying null shall go, you are saying, you are not
We're
saying,
gonna
because
reject.
lower than what? Lower than the risk we have
Stuff.
agreed to take. Is that clear? So you will always ask what is
Yes.
the alpha that we have agreed to take.
And
What
sir,
is,
from where this alpha value is coming, is it derived from something or like
no,
what is
it is our understanding that how much risk we want to take of rejecting a null hypothesis which is actually true.
Yeah, because in our like medical dashboards we are having this p values, but this particular risk factor is varying. So I'm just want to understand that from where actually this is
It depends on the
derived from.
criticality. I just gave you example. No, in industrial situation, we are willing to take a risk of 5%. But in let's say medical research, or maybe in aerospace, or maybe in the defense, we don't want to take a risk of even 1%.
Right.
So
Okay.
now that is
Yes.
clear. So before any interpretation we can make, we must know Satish, Ganeshan, Gaurav, Senthil, Kush, Govindan, Purushottam, Vijay, Balaji, please confirm, Aniket, Dr. Taslim, that you have been able to understand this concept. So now
Yes, sir.
all my tests about the hypothesis testing will give me what? Will give me a p-value. Yes. Now
Yes.
let us understand what exactly is a p-value. What is the meaning of a p-value? That I will explain to you now. Now, what is the meaning of p-value? This is the meaning of p-value. We have seen this chart also earlier also. Now can
Yeah.
you see that this is the normal distribution curve? Now, knowing the how this normal distribution curve is behaving, I can draw a line anywhere. You tell me, where shall I draw, Dr. Taslim?
Yes, sir.
This is right now in the center. Okay, Dr. Taslim, you are going to help me. Please advise, where shall I draw? 1 sigma away,
Yes,
1
sir.
standard deviation away
Yes,
towards
sir.
right? Yes, I can draw it. Yes
Yes,
or
sir.
no? 1.5 sigma away
Yes, sir.
towards the left. I can draw it.
Yes, sir.
Balaji, you advise, where do you want to draw a line?
Yes, sir.
Sigma away towards the left. Okay, I can draw. Anyone can draw. Yes or no? And anywhere you
Yes.
have drawn this line, there are tables which tell me that how much data is towards the left. You tell me anywhere. You tell me, Vivek sir, draw a line at 1.75 sigma away. I will look at the table and I will tell you how much data is towards the left. And by implication, what I am also telling, how much data is towards the right. Because total data is 100%, yes or no? Aniket? Suppose I tell you that I have drawn this line in such a manner that 25% of the data is towards the left. Please tell me how much data is towards the right?
75%.
75%. Yes or
75.
no? Dr. Taslim,
Yes.
Ganeshan? If I am drawing
Yes.
this line in such a
Yes.
manner that 60% of the data is towards the left. How much data is towards the right?
Yes, sir.
40%.
40%.
If I draw this line in such a manner that 95% of the data is towards the left,
5%.
5% is towards the right,
5%.
and so on.
5%.
So there are tables which tell you that you draw a line anywhere you wish and tell me that how many
Yes,
how
sir.
do you tell me where do you draw a line? Sir, these many standards deviation. Okay, if I ask you, Ganeshan, you will tell me, sir,
Yes, sir.
1 standard deviation away, or 1.25 standard deviation away, or 1.3625 standard deviation away, whatever. But you will talk to me in terms of standard deviations. Yes or no?
Yes, sir.
And how many standard
Yes, sir.
deviations away is known as Z value. Z
value.
Z value. Z value.
So, is it?
Okay, so if I have drawn this line at 2.5 standards deviation away, what is the Z value? 2.5. I have drawn this line, let's say 3 standard deviation away. What is the Z value? 3. Confusing? You tell me where you would you want this is 0 standard deviation away. This is 0.5 standard deviation.
5 standard deviation.
What is the Z value? 0.5.
The Z value 0.5.
This is 0.75 standard deviation.
0.75 standard deviation.
What is the Z value?
What is the Z value?
You tell me, Ganeshan, where shall I draw? How many standard deviations?
How many standard deviations?
So in this situation, G value is equal to the
Yes. So now you are very clear. Ganeshan, you are looking somewhat worried. You tell me where shall I draw?
You tell me where shall I draw line?
Where do you want to draw? 1 standard deviation away. What is the corresponding Z value? 1. 1.5 standard deviation away. Gaurav, you want to say something?
Sir, this shows कि G value is equal to the standard deviation.
The line I am drawing.
The line I am
is
drawing
how many
is
standard
how many
deviations away. Gaurav,
equal to the standard deviation.
Based on your instructions. Tell me where you do want to.
Tell me if you want to.
Me.
For example, I draw it line into 2 sigma, 2 standard deviation.
2 sigma, that
2
is 2 standard
sigma,
deviation
that
away.
is 2 standard deviation away.
Yes.
Z value is 2.
Z value is 2.
You want to draw
No, it's
2.5
a-
You want to draw
deviation away.
2.5
Z value is
deviation away.
2.5.
Z value is 2.5.
Okay. So it's a mean कि G value is equal to the my
How
standard
many
deviation.
standard
How many
deviations it is?
standard deviations it is?
And for every
And for
location, there is a corresponding p value also. Okay,
Yes.
p value
okay,
is
P value is
the probability of
The probability
getting a
of
data
getting a data
equal to or
equal
more
to
than,
or
why it is
more than, why it is
okay, just